Welcome. We're on question 3 of Study Club 1. Okay. So again, what's important is our notes, not really circling the right answer. So question 3, let's take a look. Find the coordinate of P along a line segment with these coordinates at a ratio of 3:2. So that's the information I need to copy on my piece of paper. The coordinate is -4, 8. B is 16, -2. And again, you can print graph paper off the internet if you want, or you can simply kind of make it on your own if you don't have graph paper. You don't have to have it to get full credit. And then they want a ratio that is 3:2. So we learned in class that that means that we must cut it into 5 equal pieces. Because what a ratio of 3 to 5 means is that if we simply had a line segment that was 8 long, okay, or excuse me, 8's 5 long, if we had a segment that was perfectly 5 long and it was perfectly horizontal, a ratio of 3:2 means you go 3 and stop, leaving 2 left to go. So notice that this location right here would be at a ratio of 3:2. 3 and then 2. 3 we went and 2 left to go. Notice that's why we need the number 5 to show up in our problem. So let's go ahead and graph. Just with a little planning here, I need to allow a -4 imaginary graph. I need to go -4, +8, and then I need to go 16, -2. Okay. Maybe this will be enough room for me. Okay, so I need to go a -4, 8. Okay. So something like that. -4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's -4, 8. And then 16, -2. Okay, keep on going. And then a -2. A 16, -2. So, using a straight edge, I need to connect these 2 lines. And that's a really far way to go. And it's really hard to cut a line that long into 5 equal pieces. So I'm better off making a triangle and cutting one side in 5 equal pieces and this side in 5 equal pieces, and then figure out where I'm going to go. But I'm pretty sure, just like in this little example, I'm pretty sure the point is somewhere along in here. So I went on a journey from A to B, and I went so that I went 3 equal paces and had 2 equal paces left to go. So somewhere in there. Now I can kind of ballpark it here. It looks like 8, 2 is that coordinate. And so that's one strategy. You could go ahead and graph these. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Okay, so that point right there is choice A. 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, that's choice B. So both of these are kind of in the running for 3:2 location. Both are on the line. The other one, 4, 4, is here. Well, that doesn't look 3:2. That actually looks quite a bit closer to A. And we want to go 3 from A and have 2 left to go before we get to B. The last coordinate is a -1, 6. So we pretty much can eliminate these 2 choices, and we're really trying to just narrow it down between these 2 remaining. Okay, so let's do it. We've got to cut everything in 5 equal pieces. So as I count these boxes, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number 10 is pretty easy to cut in 5 equal pieces. I just need sections of 2. So as I look at sections of 2, I can just hop by 2s. 2, 4, 6, 8, 10. And again, using this concept, I need to go 3 and then leave 2 left to go. Okay, so I pretty much know that this is, I pretty much know it is choice A, the coordinate 8, 2. But let's keep going just for the sake of argument. And another way to get this 10 without graphing is notice vertically the distance between 8 and -2 on a number line is 10. So you could have got it from that as well. Now here, kind of using that same theory, it looks like the x values are 20 apart. We have -4 here, 1, 2, 3, 4. And then we know this is 16. 16. So if I count the whole thing there, we have 20. And it's pretty easy to cut 20 into 5 equal pieces. That would be 4. Okay. So I need to go 4 at a time. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And once again, I need to go 3 equal places with 2 left to go. So here it is again. Notice that that is that coordinate. Awesome. Now next question. It says choice 4. They give us a picture and they want us to figure out, choose the construction that illustrates what the heck it is that they're doing. So I think what's important here is understanding, I'm looking for, that they're using a compass to make something. So on another piece of paper, I'm going to try to just do the same thing they're doing. It looks like they made a line, AB. Okay. It also looks like they used a compass, and so we can use any object, like a paper clip of sorts, and have the clip hold the spot, right? And then use it as a compass. So use it to kind of make an arc. And there, I've done that. And that's exactly what it looks like they've done in the picture. Then they used a compass. So I'll go over here. And again, you can use a clip or a paper clip, a hair clip. It doesn't matter. Anything can be, anything that's going to hold in place will be used as a compass. And it looks like where their arcs met, they called that Q. I'm also noticing up above here that they have a point P. So it looks like if we finished doing what they're trying to do here, it looks like they're going to make a line and connect. They always make lines connecting points. So it appears as if they constructed a line perpendicular to a given line. Notice line AB. And if they would have finished out the problem, the purple line would be perpendicular if they finished out the problem with a straight edge. And so question 4 would be D, constructing a line perpendicular to a given line. All right. So let's try to fit in question 5. We have 2 lines here. We might only be able to fit it part of the question. When 2 lines meet, something very special happens. You get 4 angles, okay? And we know that usually 2 are obtuse, and those are equal. Angle 1 is equal to angle 3. We also know angle 2 is equal to angle 4. Simply by folding our paper, we can notice that would always happen. We also notice that if you have a straight line, angle 1 and angle 2 would have to add together to be 180. Or I could move my hand. Angle 2 and angle 3 would need to add together to be 180. Or 3 and 4 would also make a straight line. This is the linear pair postulate. Last but not least, I could do angle 4 and angle 1, and those also would need to add up to 180. So these are my possible choices to pick from when I get a question like this. So when I look at question 5, I want to pick things that have the same variable. And these look like division signs, but they are not. So that's just what a copier does. So I noticed that these two vertical angles should be equal, and they both have a letter Y in them. So I'm going to set those equal to each other. So that's like in my figure here. Angle 4 is equal to angle 2 in my figure because of vertical. Now one angle is listed the expression 2y, the other y plus 10. So when I subtract y on both sides, I get 1y is 10. So now I pretty much can eliminate my choices of A and C. Now let's continue. Notice that these both have D as well, and they should be equal. So angle 1 and angle 3 should also be equal because of this vertical angle theorem. So using substitution, 20z minus 20 should equal 15z plus 25. So when I get z's all on one side, z is equal to 9. That's choice D. Check out the next video.